Hello, this is Kevin Rice, and I'm explaining the Calculus AP/AB exam from 2005, free response question number 5, Form B. So, the question is to consider the curve given by y squared equals 2 plus x times y, and we're supposed to show that dy dx is equal to y over 2y minus x. The first thing we're going to do is differentiate implicitly. So, the left hand becomes 2y times dy dx because you have to remember that the derivative is with respect to x, and so you have to multiply by dy dx because of the chain rule. And the right hand side, the 2 goes away, the derivative of a constant is just 0, and using the product rule we get x dy dx plus y. Then we move all the factors with the dy dx to the left-hand side, so 2y times dy dx minus x dy dx is equal to y. Third, we factor out a dy dx. And finally, we divide by 2y minus x to get dy dx is equal to y over 2y minus x, which luckily they asked us to show that, so we must have done it correctly. Now we are to find all points xy on the curve where the line tangent to the curve has slope of 1/2. So, just remember this is what we found for dy dx. And now, if dy dx is equal to y over 2y minus x, then you say, hey, y over 2y minus x, which is our slope at a point, the tangent line, has to equal 1/2. Then we can just cross multiply, say that 2y is equal to 2y minus x. Subtract 2y from both sides, and we get that negative x is equal to 0, so we can say x is equal to 0. And now we know that when x is equal to 0, we can just plug x back into the original equation and get y squared is equal to 2, as the x times y factor goes to 0. So y is equal to positive or negative square root of 2. Don't forget that there are two solutions, and those are your 2 points, because x was equal to 0. So 0 radical 2 and 0 negative radical 2. The next question is to show that there are no points xy on the curve where the line tangent to the curve is horizontal. So we set dy dx equal to 0. So y over 2y minus x is equal to 0, and that's going to be equal to 0 when y is equal to 0, as you see there. And now we're just going to plug y equals 0 back into the original equation, just like we did in the last question, plugging x in is x equals 0 in, now we're plugging y equals 0 in. So 0 is equal to 2 plus x times 0. Now wait a second, 0 is never equal to 2, no matter what x is. So you know that there are no points xy where the tangent line is horizontal. Now the fourth and final, is to let x and y be functions of time that are related by the equation y squared is equal to 2 plus xy. At time t equals 5, the value of y is 3, and dy dt is equal to 6. And we're asked to find the value of dx dt at time t equals 5. So this is pretty similar. You have the same y squared equals 2 plus xy equation. The only difference is now, when we differentiate implicitly, we have to do it with respect to time. So 2y dy dt is equal to x dy dt, just like in the last one. The 2 is a constant, becomes 0. But now you have y times dx dt, because before we were doing with respect to x, and the derivative of x with respect to x is just 1. But now you have to take into account that the derivative of x with respect to time is not going to be 1. So now we're just going to plug y equals 3 into the original equation y squared equals 2 plus xy, so that we can find what the value for x is when y equals 3. Solving for x by saying 3 squared equals 9, 9 minus 2 is equal to 7, and 3x is equal to 7, so x is equal to 7 over 3. Now we plug in y equals 3, dy dt equals 6, those two come from the directions, and x is equal to 7/3, which we just solved for, and we find that 2 times 3 times 6, we're plugging this into our implicitly differentiated equation, is equal to 7/3 times 6 plus 3 dx dt. Now, simplifying, we say that 36 is equal to 14 plus 3 dx dt, and finally, solving for dx dt, we get that dx dt is equal to 22/3. Okay, great. Thank you for watching.